introduction today, and for the first exam paper, we're just going to do the introduction with right-angled triangles. So this is a right-angled triangle. There's theta, and we label this then as the opposite side, the hypotenuse, and the adjacent. What you've learned so far is the rule of Pythagorean. So if this is my triangle ABC, then we know that AC is equal to the square root of AB squared plus BC squared. So this is to determine the third side. If you want the hypotenuse, you add. If you want one of the other sides, you're going to subtract, because the hypotenuse is the longest side in there. So for example, if I have the triangle 5, 4, 4, and I have to find this value here, then I can say, and if you use brackets, 5 squared minus 4 squared, then you immediately get the answer of 3 centimeters. So that is then Pythagorean. So if you look now in your textbook, on page 439, that's where we get try now 1. We're looking at that first one there. And that exercise is absolutely about the Pythagorean formula, what you have to use there. So I'm going to draw for the first one now for you a sketch so that you can see. AC, so this is triangle ABC. Remember, the middle one of ABC is, oh no, sorry, I see they indicated different here. They say C is 90 degrees. Usually it's the one in the middle, but C is then 90 degrees, so it will be A, B, C. C is the 90 degrees. Now AC is 20, BC is 15, so the sketch will help you. And we have to find AB now. Do I add or subtract? I'm going to add. So this one will then be 20 squared plus 15 squared. You can use your calculator. The square root of 20 squared plus 15 squared close is equal to, and my answer is 25. 25. So we can do the same now with the next ones. Number 2. So again, I have a right angle triangle. We have to label them, otherwise we won't know where is which angle. So that one is E. This one will then be D, and that one will be F. D, E, F. So DE is 5. EF is 12, and we have to find this one. Are we going to add or subtract? Add. So we can say that DF is then equal to 5 squared plus 12 squared. I add because I want to find the hypotenuse. So that is then 5 squared plus 12 squared. And the square root of that is 13. Is 13. Okay. Number 3. Now we have triangle KLM. So L is 90 degrees, KLM. KL is 7, ML is 24, and again we want to find the hypotenuse. So that means that we're going to add them. So it is then 24 squared plus 7 squared, and the answer is 25. Press your calculator and make sure that you get that answer there. Right, try now 2. So I keep on drawing the sketches. This time Q is 90 degrees, PQR, and now we say QP is 15 and PR is 39. Now we want to find the other side, and that means that we're going to subtract. So this time it will be 39 squared minus 15 squared. And again, we can do it on the calculator. The square root of brackets, 39 squared minus 15 squared, it will be quite a large number, is equal to 36. So you must just make the decision, am I going to add or subtract? What am I going to do every time, add or subtract? Right, the second one. So this is triangle STU. T is 90 degrees, so STU. TU is 14. SU 50. And we have to find ST. Are we going to add or subtract? We're going to subtract. So it will then be 50 squared minus 14 squared. In brackets there. So it is then the square root of brackets 50 squared minus 14 squared, close the bracket, is equal to, I got 48. 48. Right, now number 3. VWX. This is 90 degrees here at V, so it's VWX. This one is 10.5, and this one is 17.5. So it is again a subtraction sum, 17.5 squared minus 10.5 squared. And we use our calculator, so it's the square root of brackets 17.5 squared minus 10.5 squared, close, is equal to 14. So this is equal to 14. Good. Now you will see number 4 is now a mixed exercise where we're going to find those. And the question is, do you add or subtract? Do you add or subtract? So question 4a, what will I do? Add. So this one is then 12 squared plus 16 squared. So on our calculators, square root, brackets, 12 squared plus 16 squared, close, is equal to, and this one's answer, x is 20. The next one, number B, now I'm going to subtract because I want the other side. So it will be 19 squared minus 9 squared. 19 squared minus 9 squared. So it's the square root of 19 squared minus 9 squared, close, is equal to, and I have 16.3. Remember, we round off to 3 significant figures. The sides are to 3 significant figures. Number C, are you going to add or subtract? I'm going to subtract. So it will be 26.4 squared minus 12.3 squared is equal to, okay, and we can do that one again then, square root of brackets 26.4 squared minus 12.3 squared, close, is equal to, and I have 23.4. 23.4. And then the last one there, number D, and that one is again an addition one, so it's 11 squared plus 12 squared. And what do we get? 11 squared plus 12 squared. So it's the square root of 11 squared plus 12 squared, close, is equal to, and I have 16.3. 16.3 centimeters. Okay, so this is what you did in grade 9. It's not new work here. Now, the exercise 3 and 4 are about mixed exercises, but it's still based on Pythagoras. So I would like you now to do those sums. It's just a combination of what we've done here. And then we're actually going to come to the algebraic ones in number 5. So I'm going to explain there a little bit more. Try now 5. So the others are just mixed exercises. You can do them and mark them at the back. Let's look at try now 5, where we have algebra also in here. So this is on page 442. The school field is in the shape of a rectangle, and it has those sides there, x plus 7 and x plus 9. X plus 9 is the hypotenuse there. Calculate the value of x. Calculate the value of x. Now, we're going to do the same thing here. X is one of the other sides, so I actually have to subtract. So now it becomes x plus 9 squared minus x plus 7 squared is equal to x squared. That's applying Pythagorean. The longest side is your hypotenuse, and there we write it out like this. Now, we can now cancel, this is actually equal to x. If we lift the root here, then we can square it also on that side. So if I square here, the square and the square root will cancel out. So then I'm also going to square on that side. Now it's just a little bit of algebra that I'm going to use here. We did the algebra last year. Just remember that this is x plus 9 times x plus 9 minus, and I will put it in separate brackets here, so it's x plus 7 times x plus 7 is equal to x squared. Sometimes they will ask you to show it by using Pythagorean. Now here we multiply, first with the first, last with the last, inner, outer. Can you remember? So this is then x squared plus 18x plus 81 minus, I'm first going to deal with it here in the brackets, so it's x squared plus 14x plus 49, which is equal to x squared. Quite a large sum. Now here all the signs are going to change because I multiply a negative 1 in each one there. So then it is negative x squared, negative 14x, negative 49, which is equal to x squared. Okay, so this x and this one will cancel out. And I'm going to take them all over to the other side. So 0 is equal to, so that x squared remains now there. This 2 will cancel out. What is plus 18 minus 14 is 4. And I take it over, so it becomes minus 4x. Remember, I all take them over to the right-hand side now. And what is 81 minus 49? Positive 81 minus 49 is equal to 32, but I'm taking it over, so it's minus 32. So now I must factorize it as a trinomial. You can see the algebra is all in here. So x and x, what is the factors of 32? That will give you a 4. 8 times 4 is 32, so that will be my choice. So I have an 8 and a 4. Signs differ. The biggest combination is negative. So this one is the biggest combination. So this one is negative and this one is positive. Check back. Negative 8 plus 4 is negative 4x. And now we still have to find the solution. So we're going to say 0 is equal to x minus 8, or 0 is equal to x plus 4. So that means x is going to be 8, or x is going to be negative 4. And in this case, which one will we choose? The positive one, isn't it? Because it's a rectangular field, so we can't have negative ones. So you have to indicate that that one is your choice, that you choose that one.
Win free airtime with hashtag LearnOn1. Share your comments on the lessons. SMS your feedback, name and town to 555. Hashtag LearnOn1. Invite learning in.
Second lesson on trigonometry. So we're looking now at try now 5 on page 442. Try now 5 on page 442. So this is still Pythagorean that we are looking at, but now they combine it with algebra. We're doing number 2. Number 1 was on yesterday's lesson. So a campsite in the shape of a rectangle has the sides. Find the area of the campsite. Now, before we can do that, we need x. We need to know the value of x. And the only thing that we have here is Pythagorean. So we can say that 3x plus 6 squared plus x plus 1 squared is equal to 4x plus 1 squared. There's your Pythagorean that we do. So now we have to multiply this out. Now remember what we said. This means it's 3x plus 6 times 3x plus 6. Don't be lazy to write it out because otherwise you're going to lose your middle term every time. So now I'm FOIL. First, last, inner, outer. This is what we're going to do. So this is the 9x squared. This is 18x plus another 18x, so it's 36x plus 36 plus, so now I'm taking this one, so it is x plus 1 times x plus 1, which is then x squared plus 2x plus 1 is equal to, and on this side, 16x squared. Remember, there's another 4x plus 1 there, plus 8x plus 1. So now we collect them all on the one side. So 9 plus this 1 is 10x squared. If I bring that one over, it's negative 6x squared. Here, 36 plus 2 is 38. If I bring this one over, change the sign, 38 minus 8 is then plus 30x. And here the 36 plus the 1 is 37, minus 1 is 36, is equal to 0. Now it's always easier to get rid of this negative, and I can simplify this whole equation by dividing everything by negative 6. So then I have x squared minus 5x minus 6, which is equal to 0. And now we're going to factorize this one. This is an easy trinomial. Remember, we did it last year. So what times what gives you the first term? X times x. Then we take the factors of 6, which might be 2 by 3 or 6 by 1. And now we read it. If you subtract it, it must give you 5. If you subtract it, it must give you 5. So it will be this combination. So it is 6 and 1. If there is a negative, it says signs differ. And this one tells us that the biggest combination is the negative. Now this is what I mean with a combination. So this one must be negative and this one must be positive. So x is equal to 6 or x is equal to negative 1. We choose the positive one because it is a rectangle and you can't have negative values. And now we can finally find the area. So if we go back now to these sides, now what is area? We said area is half base height. So we need to use the base and the height, these two. If you put the 6 now in there, 3 times 6 is 18 plus 6 is 24. So the one side is 24 and the other one is x plus 1, which is 7. So half base height to find the area now, that's what we want, is then a half of 24 times 7, and the answer is 12 times 7, 84 square centimeters. 84 square centimeters then for that one. Half base times height. Okay. Right, let's look at number 3. A folded napkin has a triangular base. So there's the napkin and I fold it there. Now remember, there's my 90 degrees. The longest side is always opposite that hypotenuse. Now you have a plus 1, a plus 2, which means this one is the longest side then there. That one is the longest side. And one of them is then a plus 1 and the other one is a. And again, we can find a by using Pythagorean here. So I can say that a squared plus a plus 1 squared is equal to a plus 2 squared. So this is a squared plus 2a plus 1, which is equal to a squared plus 4a plus 4. Again, if I bring them all over, remember if there's nothing, there's a 1. So this is 2a squared minus that 1 is a squared. Then 2a, if I bring this one over, it's minus 2a, so negative 2a, and plus 1 minus 4, if you bring it over, is negative 3 is equal to 0. So now we can factorize this one. So it will be a and a, 3 and 1. Signs differ. It tells you again signs differ. And the biggest combination is negative. This is the combination like this. So this one is negative and this one is positive. You can always check them back. So now we're going to solve it and say a is negative 1 or a is equal to 3. Which one do we choose? We choose the positive value. We choose the positive value. And then, yeah, the question is just find the value of a, so that will be that one's answer. Okay. Right, now we go to try now 6. Try now 6. Copy each of these triangles and label the side as hypotenuse, opposite, and adjacent. So they just want us to see which one is which one. So there's the first one, 40. So you always start with a marked angle. So that one is opposite the marked angle. The hypotenuse is always opposite the 90 degrees. And this is then the adjacent one. Adjacent means next to. If you can't identify the sides, you're really going to struggle with this trigonometry. So this exercise is very important here. This time, this one is the marked angle. We start, let your eyes go to the angle. So obviously this one is going to be the hypotenuse, opposite the 90 degrees. And this one is then opposite from that 35 degrees. That one is adjacent. Number C. Now first try this one on your own before you listen further to my recording. That one is 90 degrees. This one is marked 37. So which one is opposite the marked angle? That angle there. This one is the hypotenuse. This one is adjacent, next to the angle. Next to the angle. And then number D. So we have that little triangle there. That angle is 42. This one is 90 degrees. So this will be the hypotenuse. This one is the opposite one. And that one is adjacent. Identifying them. Now, from that, we have now our 3 trigonometric ratios. So the following is now very important. So we have sine theta, which is opposite over hypotenuse. And you need to learn this. You need to learn this and know this. Cosine theta is adjacent over hypotenuse. There's the second one. And the third one is then tan theta, which is opposite over adjacent. So that is your 3 trigonometric ratios. So they talk about SOHCAHTOA, that's how you can remember it. But if you can't identify the sides, then you can't do the sums. So let's look at the sine one, and there's your marked angle theta. Theta is a Greek letter for any angle then there. It might be A, B, X, Y, Z. But we usually use theta then here. So when will I use the sine theta? I will use it if I have the opposite and the hypotenuse. The opposite and the hypotenuse. So the sides will tell you which function to use. The second one is now this one. There's theta. And this is still the hypotenuse, opposite the 90 degrees, but now this angle is adjacent. Cosine theta, it's the included angle, cosine theta. And here, another right angle triangle. So if this is theta, that one is opposite, and this one is adjacent. And actually tan is easy to recognize because there's no hypotenuse involved. Then it's tan. Cosine theta, the included angle here, and sine theta where you have opposite over hypotenuse. Now, when we do our questions from here, we're going to ask 2 questions. Which function? Which function? And then the second question that we're going to ask is which method? Which method are we using here? Which method? Which function? Which method? That is the 2 questions that we're going to repeat every time. Okay, so we look now at try now 7 on page 444. Try now 7 on page 444. For each of the following right angle triangles, find sine, cosine, tan, and we just have